Hey guys, I thought I'd give a sneak preview of my new controller. This is for my Joe's Wreck and Pinion 4x4 hybrid. I'm building a new machine and I thought we'd step it up with the new controller. It's kind of an accumulation of probably about 2 years of work with design and a pretty good amount of engineering to get everything to work. Obviously I started with the box much bigger than before. It's 20 by 24 by 8 inches, and sure enough I just barely fit everything in here by the time I was done. So I'll give you a little show of the system, how it works, and some of the basic design principles I incorporated in this system that I didn't have before to make it dynamic for using with the future, depending on what kind of setup I have in the future. So we'll start off. This is a basic, this is a wide, very heavy duty steel box, a commercial industrial box. Start at the door panel. I'm just going to swing this up. At the door, and I've got this on the bench, so it's kind of hard. Before I mount it on the machine, I thought I'd give a video because it's a lot easier to show. I've got my traditional e-stop on-off button, rotary disconnect, which ties into the disconnect at the back panel, and then a multi-function panel meter, which reads in volts, amps, and hertz, as well as watts. So it gives me a lot of different functions that I can read without getting in there with the panel meter, or without a traditional meter for reading, which should help me partly with load calculation of something I've always been interested in, to be able to watch numbers fly as you're cutting, so you can see how hard your machine's working as a system, and translate amperage into machine power. So anyways, coming into the box as well, as we've got, this will be where my cables will enter. This is a Roxtec Easy 16 entry gland system. Really recommend it. Really good system. It allows you to put all the cables in the box, regardless, whatever it is, parallel port cable especially, without cutting them. They're split glands. A lot better than your traditional cable gland for this application. I've also got a big, large 4-inch, actually sorry, that's probably like a 6-inch industrial fan from Rittal. I ended up having to make a spacer out of MDF for it because it wasn't big enough to get me the space I wanted inside here. You can see how close I've got the fan to the wire duct itself. I've also got an exit point up at the top of the box for hot air to exit, although there's no fan. It's just a point of exit for hot air, if there is any. And then obviously we've got our geckos here. The main core of the system, we got 5 gecko drives for X, Y1, Y2, Z, and then potential 4th axis or any other use. Could be used if one goes bad, if I need to switch over for any reason. And I've got them mounted on a pretty stout heat sink, which was I milled down on risers, all aluminum. I've also tapped in 2 4-inch muffin fans on the bottom, blowing cool air. So I'm hoping that this heat sink will stay extremely, actually cold, rather than just keeping things cool. And that's the plan. On the back side of the door, you'll see that I made a neat little harness coming up, which should work really well. Even though I'm not in this cabinet a lot, I wanted to dress it up so that there was no working on the individual conductors themselves. Come in, here's the back of the panel meter, simple voltage in, 120 volts in, 115 nominal. And then I've also got this clamp on, actually pass-through transducer. It measures amperage. And then I just nipped it and have a plug-in woggle connector, which helps me passing that wire up. That's what that guy is, just tied to that timeout. Back of the disconnect here, and then back of the on and off button, and of course the e-stop. Now coming in from the penetration at the bottom, and sorry, there's kind of a mess. I've got jumpers here, and then I've also jumpered the PE because I haven't stripped out this power cable long enough to put it in a wire duct, and it's probably not the one I'm going to use. I've also got jumpers to complete my e-stop circuit for now, because there's no field connections at this point, just sitting on the bench. But coming in, I've got my terminals here for X, Y, 1, Y2, and Z, and then the potential, even though I didn't pre-wire it, I've got everything in place to wire that 5th guy in there. These are also my 4 proximity sensors, the 8mm proximity sensors, and then here's my 2-tier terminal for my aluminum touch plate or any other kind of touch plate device on the machine, which is wired up to the PMDX. These terminals here are in sync with the e-stop circuit, both on the auxiliary contact monitoring the circuit breakers and also on the live 115 side in sync with this push button circuit. Basically I'll be monitoring it on a low voltage level on the PMDX side, monitoring the state of the devices, as well as on the high voltage AC side, so that if I lose power that it goes off. So there's no way this system can function if the e-stops are hit or if the router spindle stops. It'll completely disable itself, even without me interfering with a mechanical e-stop on the machine if I get tied up. Coming here, something you guys will recognize, this is your traditional AC contactor. Power comes in from the disconnect, comes down to the contactor. Off of the contactor, I take a line, I bring it up to the panel meter to register my usage. I bring it back down to AC bus. AC bus, here's my line, neutral and PE. PE is tied into the DIN rail. It also grounds the back panel because it's just the way I screwed everything in. Line comes over to one of my first circuit breakers to give me my overall circuit protection, even though I've got upstream. The ones in my house are the older GE style, and they don't give you as much as you need. So I brought in circuit breakers at a local level inside the panel. Coming off of here for circuit breaker 1, which is for the master DC power supply, AC to DC power supply. Circuit breaker 2 is coming over to the solid state relay, and that's protecting my router. And also this is an auxiliary contact, like I said, is monitoring the state of the breaker, so that if for any reason this spindle loses power, I don't want the machine running, obviously, if that's because you're going to break a bit and hurt the machine potentially or start a fire. So this will automatically turn off the system on the PMDX side, as well as a full system power. There's no way it can run. Pretty stout solid state relay. This is a Carlo Gavazzi solid state relay I showed in my other video, powering on the router dynamically. Basically, here's my signal here coming from the PMDX output relay, and the PMDX sends the signal to here. Obviously, the PMDX that I have is not rated for it, nor would I want to use the onboard relay in case I fry it and then I'm screwed. Then I can't replace. It's not user replaceable. Comes through here. This solid state relay has got mounted on a heatsink, which is why it's so tall. So I've already got my line in, and then T side. Consumer side, I'll wire directly to this solid state relay. I won't even stop at a field terminal. I just didn't have enough space. So that's AC side. AC comes up to your power supply. This is 11 or 12 amp power supply. I got a 56 volt DC output, even though it comes out really at 54. Comes over to my DC bus. I've also got a 12 volt and a 5 volt output. I'm using just a 12 volt to power the relays, these interface relays for my proximity sensors, as well as my PMDX, which is a nominal 12 volt DC. Coming over here to bus, and then individual fuse protection for all the Gecko drives, including expansion 1 that I've got, even though I haven't pre-wired it yet. And then my 12 volt fuse protection, as well as negative bus as well. So that's coming up to the PMDX for power on, as well as powering these interface relays down to their field terminals for giving 12 volt power to operate those, as well as operate the proximity switches themselves. And then off of the PMDX, I got to run in the parallel cable and strap this guy up here, which I'll probably do with a cable timeout. I've got my 3 main axes. I twin ferruled the Ys together so that I could save space for this 4th one without ever having to change it later on. I would just have to bring in a cable for this guy. And then those basically come over to the Gecko drives. Gecko, everything's individually fuse protection. I'm using 5 amp fast blow as per recommendation, even though these are internally fused. I wanted some higher level fuse protection beyond that coming in, because they are user replaceable, but they're not easy to change inside there like a regular fuse is. There's some debate that these would blow first, which would be a good thing, but if any reason the other ones blow, they're a lot easier to change. They're just easy to flip top fuse change, pop them out. It's a 5x20 millimeter fuse, European style fuse. Then you got our 4-phase wires, phase A, phase B, step direction and common, and then our current set resistors on all of these. And even though these conductors for the phases aren't labeled with wire markers like I did, because this is just smaller and you would have slid them off anyways, the conductors themselves are numbered 1 through 3, and then the ground is easy to spot. And those go down to your feed terminal. And I use terminal strip drawings that I've created in schematics, which I keep on board on this guy, paper holder. So the geckos come out to there. That's pretty much it. I think in my next video I'll show all this stuff working. I think I'll just give you a quick demonstration, power everything on. I'll just plug this guy in on the wall. Now power is applied in, and I got the power cable that I've just playing with this to show it on the bench, and so I'll have to turn the rotary disconnect manually rather than with the door. I'll flip this door up, I'll hit the on-off button here, and you'll see that it illuminates when I turn it on. So now I got this nice illumination light telling me what's going on. And as you hear, the system's powering on. I've got 118 volts. And I'll come over here and about 600 milliamps. Very low usage, 62 watts, 60 watts about. And it's running at 60 hertz, North American. You can hear that fan going. It's loud, but the machine I figured is much louder, and I'd rather have much better air quality than the latter. So now everything's live. You can see my gecko drives are powered up. You see their status lights, and everything's hot. The MDX is lit up a little bit, even though I don't have the parallel port and giving me everything else. And the relay lights will go on as they hit. They'll be on all the time to maintain that normally closed circuit, but because I don't have the field wires in, they're not going on right now. But hopefully you enjoyed my new controller. Take any questions you have, please feel free to comment, and I'll show a video when I got this mounted on my machine with everything hooked up. I'll give a demonstration of how it all works. Thank you.